You say, well, I didn't know it was a difficult place. I was just born. And that's lucky for you and me that we were just born and we didn't have all the intellectual, historical, sociological, psychological background, because otherwise life would be hard for us. Think about, well, you can't maybe yet, but when you're 40, think about reliving your teenage years. And that's the kind of thing you would have to face if you were born with what I'm about to tell you now. 20th century, in terms of literature, has been preoccupied with scientific ideas which have redefined reality. The universe becomes a discontinuous place, and that has to do with quantum physics. Let us go then, you and I, when the evening is spread out against the sky, like a patient etherized upon a table. Oh, that's what sunset looks like. Go out tonight and look at the sky. And if you see a patient etherized upon a table, what? Call Parkland. They'll come for you. You see right away how really the universe becomes a discontinuous place. And that has to do with quantum physics. Discontinuity. This poem was written about 1920. And it totally shatters the 20th century. It's a very great prophetic statement here. Because Eliot hadn't read any of this stuff about quantum physics, and yet he felt it in his heart, so to speak. And he wrote about it from that point of view. What's it like to be a man adrift, like a patient etherized upon a table? A man adrift in time and space that are relative and uncertain. That's Prufrock. Let's look at Prufrock and we'll know what Eliot thought it was like. Now, you and I are very much more practiced, aren't we? After all, we've had another 64 years to deal with it. We're used to walking in fog. Let me first begin by talking about another scientific revolution in the past, which had the same effect upon people, causing the same kinds of insecurities, alienations, and doubts that people might experience today. I refer, of course, to the Copernican Revolution. Galileo was almost burned at the stake for suggesting that the sun was the center of the solar system and not the earth. This made a very big deal out of everything because poets at the time, John Donne, wrote that new philosophy calls all in doubt. And I think we can see an instance of the doubt that was raised for those people in this. The Greek idea of our solar system, which said that the earth was the center. So the Greek, Roman, and medieval science for thousands of years posited or assumed that the earth was the center of the solar system. But here comes Copernicus, here comes Kepler, here comes Galileo, and they have scientific proof that the sun is the center of the solar system. Of course, they said universe. You can imagine what this did to people. It certainly seemed to make man, human beings, less important than they had thought that they were. When Galileo says the sun's the center, not the earth of the solar system, that confronts science from Egypt. But Freud's idea about the inner nature of man really just confronts what we might call 19th century optimism. The Victorians, they thought that the nature of man was at least a certain thing, and that it was tended toward the good. But Freud suggests quite the opposite. Depth psychology suggests that inside of man, woman, human being, there lies this seething cauldron of emotions and repression, which make him behave in the way that he does, but often give the lie to what he says. So we have the Oedipus complex, the Electra complex, and so on and so on and so on. Well, that's old hat. And you've heard of it, and you know about it to one degree or another. What I'm going to say today, and probably continue next week for a time, is to present you with what's called quantum physics, or quantum ideas. Now, quantum physics isn't restricted just to physics. There's a quantum chemistry. So beginning then at somewhere near the beginning, if you refer to the board, you'll see an attempt there to schematize the two as they oppose one another. We, of course, know that the father of classical physics from our point of view is Newton, who discovered gravity, among other things. And the father of quantum physics is Einstein. Although, as a matter of fact, Einstein turns out to be one of the great disbelievers in quantum physics as we know it today. Einstein said, God does not play dice with the universe. Quantum physics says that's all the universe is dice play. I'll show you what I mean. To begin at the beginning, the classical physics view of the universe is essentially deterministic. Determinism in this case should be viewed as a kind of a clock. The universe is a clock. God wound it up, set it in motion, and it runs itself according to these immutable or absolute laws of motion. And then God left it and went off to meditate somewhere. Let me read this to you. Nothing is left to chance in the deterministic universe. The future is as precisely determined by the past as is the forward motion of a clock. Although our human minds could never in practice track the movement of all the parts of the great clockwork and thus know the future, we can imagine that an all-knowing mind of God can do this and see past and future time laid out like a mountain range. This rigid determinism implied by Newton's laws promotes a sense of security about the place of humanity in the universe. All that happens, the tragedy and joy of human life, is already predetermined. The objective universe exists independently of human will and purpose. Nothing we do can alter it. The wheels of the great world clock turn as indifferent to human life as do the silent motion of the stars. In a sense, eternity has already happened. That's determinism. Incidentally, I'm reading to you from a book called The Cosmic Code, Quantum Physics as the Language of Nature by Heinz R. Pagels. This author goes out of his way frequently, and I guess tediously, to remark again and again and again that the idea of God that used to exist can no longer exist in our universe because of quantum physics. He's a little desperate to make that point. His being desperate to make that point makes me suspicious that he's worried that he's not right. So we take the knowledge or the information, but not necessarily as knowledge. Continuing then with the deterministic world, the deterministic worldview that Newton supported fell. It fell not because of some new philosophy or ideology, but because by the end of the 19th century, experimental physicists contacted the atomic structure of matter. What they found was that atomic units of matter behaved in random, uncontrollable ways which deterministic Newtonian physics could not account for. It is our purpose then to explore some of the intellectual background out of Einstein and also out of general physics as to how the universe was described by quantum physics as being uncertain, random, and merely probable. So the first thing we should talk about is the atomic structure of the universe. Now, you and I look at solids. I say solids with quotes around them. We look at solids and we say, well, that's a solid. If I walk into it, my body cannot pass through its body. And we accept that as reality. And it does have a great practical value, doesn't it? When you're driving your car and you come to a stop sign and someone else is at the other side of the street, then you do want to stop your car. While that may be apparently correct, it's theoretically incorrect. So, what is the atomic structure of the universe? Everyone take a breath. You just inhaled 1 billion atoms. If you like it, 10 to the 24 atoms in a breath. So, you see, the question arises then for us, what is the nature of matter? Is matter solid, as was assumed from earliest time up until about Newton and after, or is matter empty, which is then be the atomic view of matter? And if we could perhaps rearrange our atoms, we could then interpenetrate one another, walk through walls. This sounds like science fiction stuff, but this isn't. This is physics. Einstein had three basic ideas. I'll tell you what they are. The first one was a reason for what is called a Brownian movement. If you've taken any kind of chemistry or physics, you know that Brownian movement is when you put a very small grain of pollen in a liquid or in a gas and then watch it under a microscope. And the thing about the thing is it doesn't hold still. It starts to bounce, it starts to twitch, it starts to move. And while Brownian movement was discovered before Einstein, no one knew the reason why it was bouncing around under the microscope. Well, it turns out the reason is what? It's got atoms. Atoms. What are the atoms doing? They're bouncing off our pollen grain, and it's going, that's Brownian movement. First point Einstein made. The second was the photoelectric effect, which is simply this, that when light shines on metal, metal gives off electrons. Now, you don't have to know any more about it because everybody rides the elevator, or automatic elevators work on this principle. They send a beam of light across the doors when they're open. The beam of light shines on a metal plate on the other side, and as long as that's on there, the doors will close. But if it's interrupted, they'll open. So consequently, if the thing's closing and I walk into an interrupted beam of light, the doors open again. The third idea that Einstein promulgated was the one that we all know about, the special theory of relativity. That is simply that time and space are relative to each other. I always get a good instance of this because even though I know that, when I come to a stoplight on a slight incline and my foot's on the brake and the guy next to me starts to move, I really push hard on the brake because I think that I am moving. Einstein gives the example of a man standing on a train platform and a man in the train. Now, the man in the train, as the train starts to move, could easily think that he's not moving, but the platform is moving. And, of course, vice versa, which is the ordinary way in which we usually say it. In fact, Einstein proves that there is a different time on the watch of the man on the train than there is on the watch of the man on the platform. And he gives this example of twins. If you get two twins born at the same time, they grow up together. Then you take one, you send him at the speed of light out into space. And when he comes back, the twin who's left on Earth is long dead. But he hasn't aged. As a matter of fact, he's gotten younger. These are science fiction ideas, but they come from quantum physics. You remember now, I said that determinism is merely the idea that the universe runs according to unchanging laws, and therefore it is a fixed state. It's a steady state, stable. But the uncertainty principle, it's called Heisenberg's uncertainty principle, suggests something different. Classical physics supported the world view of determinism. According to classical physics, the laws of nature completely specify the past and future down to the finest detail. The universe was like a perfect clock. Once we knew the position of its parts at one instant, they would be forever specified. Human beings could not, of course, know the positions and velocities of all the particles in the universe at one instant, but invoking the medieval concept of the mind of God, we could imagine that this perfect mind knows the configuration of all the particles past and future. Knows them, you see, because they operate according to physical law. It turns out that according to quantum physics, there's no determinism in the universe. As a matter of fact, we do not know what will happen next. As you see, the idea was in determinism, man isn't needed. Man cannot change the universe. But in quantum physics, as I told you last time, the mere fact that man is in the universe conducting scientific experiments changes the universe. So if I'm looking at a glass slide under a microscope of some kind of behavior, biological or atomic, then the fact of my body being there, as well as the fact of the optical effect of my looking through the microscope, changes the behavior of whatever it is that I'm studying. So instead of it being determined, it's uncertain. It's uncertain because I don't know what it is. What is the universe without human beings? You say, well, we can't answer. Therefore, it's uncertain. There's a good deal more to that idea, however. But pressing on, the next idea that comes out of quantum physics is the idea of randomness. And if you've taken statistics, you're familiar with the idea of randomness. But probably you don't know that there isn't actually a definition of randomness. Probably the best definition you can give of it is that it is unbeatable. That's to say, if you go to a gambling table or a roulette wheel or some kind of machine that operates according to a random principle, you can never beat it. You can never beat randomness. You always need an edge. So if you have a system for betting. Bet every 5th time and double your, well, don't double your bet, but increase it by 10% each time. And if it's not random, and if you've discovered the non-random quality of the wheel, then your system will beat their system. But if it's random, you can't beat it. Well, the idea here is that not only is the universe uncertain, but it's also random. So that there is no, what do we say, teleology to it. There's no purpose to it. It's a random thing. You can see how scary this gets? There's one, yeah. You can see how this might affect someone's religious beliefs. It's fortunate for all of us that we're still living in the 19th century. Right? Because what kind of a human being is turned out by this view of reality? No one knows yet, right? It's still too new. Quantum physics is born between 1900 and 1924, or 1926. T.S. Eliot writes Prufrock and other poems about 1919. I'm very tempted, probably I won't be able to resist the temptation, I'm very tempted to view Prufrock's The Love Song of J. Alfred Prufrock as an allegory of the man who lives in an uncertain and random universe. We'll look at it at the proper time. Maybe you don't know what probability is. My favorite example of the statistical stability of distributions is dog bites in a large city. If people get bitten by dogs and report to doctors or hospitals for treatment, the event is recorded. Over several years, the reports number 68, 70, 64, 66, 71, an average of about 68 a year. Why is this number so stable? Why doesn't a year pass with only 5 dog bites, or as many as 500? Is there some mysterious spirit that affects these dogs and people each year so that almost exactly 68 people are bitten without fail? What, though, does the randomness of events imply for individuals of the species? You may think you exercise your freedom by promoting a specific political opinion or deciding to wear blue shoes. But in fact, your actions are just part of a probability distribution. In French society of the 1970s, there was a definite probability that a person would be on the left or right politically. What is perceived as freedom by the individual is thus necessity from a collective viewpoint. The die means the dice. The die, when it is thrown, may think it has freedom. If I have a dice or a die, and it's 1 to 6, the probability of my getting a 6th is what? 1 out of 6, sure. That's very simple, see. The die, when it is thrown, may think it has freedom, but whatever it does, it is part of a probability distribution. It is being influenced by the, quote, invisible hand, unquote. We cannot act without being a part of a distribution, and put a question mark after it in parentheses. We'll talk about that. It is like being in an invisible prison held by invisible hands. Even the very act of trying to escape is again part of a new distribution, a new prison. Perhaps this is why real creativity is so difficult, because thousands of invisible hands hold us to our conventional acts and ideas. The probability of any human act can be predicted. Therefore, are human beings free, or are they merely functions of conventional ideas? What we're getting at now will linger on. What's the probability that you should be here now, Larry?
What's the probability?
Well, you don't know, but we'd have to compute it. What the suggestion here is that there is no such thing as an original act in ordinary time and space. Everything you do has been done before by someone else. Now, there may be a greater or lesser probability that you should repeat that act, but still there is a probability. What's the probability that a Shakespeare should exist? Exactly, that's my point. That's zero probability. Shakespeare never existed before and never existed after. And yet, so there seem to be in human history individuals whose living and acting could not be predicted under ordinary terms. And yet, who are we? We are, unless one of us is special. And what's the chance that somebody here is special? Yeah, somebody here is outside probability predictions. Well, yeah, that's the idea. And yet, well, let's hold the door open, right? What kind of emotional state do you think these ideas would produce in somebody who took them seriously? What's that mean? Well, to tell you the truth, I have met a quantum chemist from Hungary at a party in Austin many years ago. He wasn't that. No, he wasn't that at all. As a matter of fact, he was the only person at the party that really seemed to me to have any kind of balance at all. So we stood around the punch bowl, and I suggested to him that I wrote sonnets. And he said, he brought his wife over, and he said he writes sonnets. And I said, you know what a sonnet is? He's from Hungary, after all. He said, sure, I know what sonnets are. Would you like to hear one? I said. And he said, yes, I'd love to hear one. So they heard a sonnet around the punch bowl at the party. I have to say that sounds to me to be somebody who's curious and open, not at all closed off to the possibilities of things. Let me say another thing about the behavior of these, what we call them, new physicists. There's a man in Austin named Ilya Prigogine who won the Nobel Prize in the 70s. And he has written several books, and he constantly is saying, I've heard him say it, that there is no difference between the poet and the physicist. That both are talking about and exploring the same principles of reality. Now, granted, physicists at lower levels don't think that at all, but physicists at higher levels maintain that almost as a dogma. So how could it be? It's obvious that we're missing something of the delight and joy that a understanding of the universe from its own point of view must bring. A definition was given of what the universe is from the point of view of quantum physics. The universe is a simultaneous explosion of individual parts every instant. What do these ideas tend to produce in politicians? You help me. Who has an unformed mind? Politicians? Teachers? But I'm suggesting that little minds or unformed minds are going to be threatened by an idea like this, you see. Well, let's imagine that Newtonian physics, or determinism, produces a tremendous sense of security in the human being, and not just in the individual, more important in the society. If you were to found a theocratic society, for instance, like the Puritans tried to do in America, and you had a scientific principle of physics to back you up which said that the universe was a secure and a stable place, then you could dictate from on high the way everybody ought to behave. And if they didn't behave that way, well, you could brand them. A for absentee. Well, another view of this deterministic physics suggested that light was a wave. And that sounds good to us. That sounds even modern to us. But it turns out light isn't a wave. It turns out quantum physics says light is particles. Photons, you've heard of photons. As a matter of fact, both are true. Light is both a wave and a particle. And you could argue that, I suppose. How could the thing be both at the same time? Furthermore, classical physics, because it has a kind of a secure basis, a definition, a determinism of everything, is an absolute kind of way of thinking. And it would be then supportive of all kinds, all other forms of absolutist thinking. Name some forms of absolutist thinking besides the Puritans. Well, there's one. It's not a way of thinking. Well, you need to maybe, let it gel. After all, you're just getting into it now. We're going to have all semester to discuss absolutist versus relativistic ways of thinking. And then, as I said before, the idea here is that matter is solid. Right? I mean, solid, right? Well, see, neither of those things just happened. The book, which doesn't exist anyway in the form that you think it exists, it's just a bunch of atoms that are strung out for thousands of miles, went through his hands, which are strung out for hundreds of thousands of miles, circulated all the way around in the universe, and then ended up on top of the desk, which isn't there anyway, which is strung out in hundreds of miles of atoms. And now is resting where? Nowhere. Nowhere. Right. Nowhere. Sure, that's scary. Of course it is. That would be called nihilism. It might be called the annihilation of the universe. Of course it's scary. But if it's real, what advantage do we have to fool ourselves? Leave that. Don't answer. Now, come over here to quantum physics. Quantum physics suggests then that, you could interpret it this way. I am not sitting in a not chair, and I'm not happy about not it. And that's not right. The other one is light as a particle, not a wave. When we talk about relatives, I don't mean aunts and uncles, right? I don't mean relatives, I mean relatives. Relatives. Should a good man steal? Yes or no? Should a good man steal? You see how already quantum physics has gotten down to us because we have what we call situational ethics. Now, if you ask Socrates, should a good man steal, what would he say? No, he would be certain of that. He's a total absolutist. But ask someone here, should a good man steal? And he'll say, well, it depends. If he has 6 babies at home and he can't get a job, and it'd be better for him to steal to feed his babies, wouldn't it? Then you're a relativist. See, that's relativistic thinking. Once you get on the relativistic train, you can't get off. The interesting thing politically and socially for us is we have this very, very peculiar mix of absolutist ideas and relativistic ideas, and they're all bound up together like 2 balls of twine, red and white twine, you see. And to pull one, for us, would mean perhaps the destruction of the social political fabric that we have maintained. Therefore, nobody wants to touch this one. Leave it alone. Unwrap it next year. And then, finally, this idea, solid matter versus empty space matter. Again, that's comical. I suppose you could do a good act on that one, right? Some kind of magician disappearing, reappearing kind of an act. The issue for us in World Lit 2 is that these ideas, which begin in 1900 and which then are kind of culminated in 1926, have been around for a lot longer than any of us have realized. And all of the time, the 20th century has been unweaving itself. Principles of uncertainty and relativism have been influencing philosophy, psychology, and literature. What we then want to try to do is to examine the modern pieces of literature in this course against the background of this view of nature and reality. So we can do no better thing right now than to turn to Eliot's love song of G. Alfred Prufrock and begin to examine some of the quantum ideas that affect the reality that poor Prufrock has to walk through. This image of the evening sky. Let us go then, you and I, when the evening is spread out against the sky like a patient etherized upon a table, knocked out, prone, and that's the horizon line. You might see the man's head here on the table as being something analogous to the sun. We know one thing about the two. The sun is going down, and who else is going down? The patient's going down. And both are going to do what? Come up again. They're both going to come up again. What do we call that? A medical image of sunset. Let us go through certain half-deserted streets. Certain? What's certain about it? He means, doesn't he, uncertain? It's a kind of a pun and yet not a pun. Certain half-deserted streets. Well, which streets are half-deserted? Go downtown Dallas at night, late at night, and how many streets will be deserted or half-deserted? Certain half-deserted streets. Well, they're all half-deserted. One could be substituted for another. The muttering retreats of restless nights in one-night cheap hotels. Oh, is this our life? In the new physics? Restless, yes, we see that. And one-night cheap hotels. Is that what it is to be born on the earth? You got a one-night cheap hotel. Who's got a popular song on that? I live in the lonely street. You know. Of restless nights and one-night cheap hotels and sawdust restaurants with oyster shells because they have sawdust on the floor. You can get oysters in London. It's kind of a seaport city. And now look, streets that follow like a tedious argument of insidious intent. You see, the streets aren't even streets anymore. The streets are a what? They're an argument. Circle streets, circle argument, draw a line between. Streets are an argument. About what? What? Reality. As he walks through London, he's walking through a kind of map of the universe, and it's uncertain. It's a tedious argument, we'll see, of insidious intent to lead you to an overwhelming question. What's the question? Where am I going? Exactly. Where are you going? You expect to live or die? You expect to die. Well, get on with it. Get out there. I mean, for now. He expects to live. Okay, where are you going? I don't know. I don't know. So that's why he says here, to lead you to an overwhelming question, oh, do not ask what is it. Let us go and make our visit. Just go out and live. But what kind of world are you living in now? No longer that world, but this world. Anything could happen. Well, the little men from Mars could land. It could happen. How many of you believe it could happen? Raise your hand. 1, 2, 3, 4. But now we've all seen all the movies. We're ready for them to land. Question?
Do you believe it?
We'll get into my beliefs at a much later date. Oh, do not ask what is it, let us go and make our visit. And now a period, notice, and a break. In the room, the women come and go talking to Michelangelo. Well, that's nice, but what does that have to do with the insidious argument of the streets and the tedious nature of the question? We'll find out later.